So, lesson 6, we're just going to start with an investigation to prove what one of the laws is, and then we're going to do another investigation to prove the second law, and then we're going to do a third investigation to prove the third law. It's going to be so fun. So the first law we're going to investigate is the product law. Before we can actually investigate, I just need to review a little bit. So do you guys remember from yesterday how I could use my calculator? How I could use my calculator to calculate this? Yeah. Log base 2 argument 16. What do I put?
16.
Base 10.
So I use a base 10, log 16 divided by log 2. And if you calculate that, what do you get? Well, let's find out. You get 4. Good. Okay, now there's actually 2 other ways we can figure this out. So that's by changing the base to 10. We have log base 2 16. Let's set it equal to an unknown variable. We'll change it to exponential form. Change the base. The base 2 to the power 4 is equal to 16. Bases are equal, so the exponents are now equal. Do we get x equals 4? Same value. Or the third way, and I'm hoping that we can catch on really quickly so we can do this throughout the whole lesson, is just to think about it. We know if we change this to exponential form, it's 2 to the power of something equals 16. Well, 2 to the power of what gives us 16?
4.
4. Okay? How about 2 to the power of what gives me 8? 3. Good. So if I evaluate, I get 7. Okay, let's just simplify this. We get log base 2 16 times 8, 128. So again, we could put that in our calculator as log 128 divided by log 2. Or we could use exponents, change base, and then solve for the unknown. Or we could think 2 to the power of what gives us 128. And if you just experiment a little bit, you will figure out that it's 7. So interesting. We have log base 2 16 plus log base 2 argument 8 is equal to 7. And we have log base 2 and the argument 16 times 8 is also equal to 7. Let's see if kind of the same pattern happens with the second example. So let's evaluate log base 3 27. 3 to the power of what is 27? 3. 3 to the power of what gives you 3? 1. So we get 4. Okay, here we get log base 3 81. So 3 to the power of what gives us 81? 4. And again, we notice that the addition of 2 logs with the same base is the same as a logarithm with the same base. And instead of adding, we're multiplying the arguments. So our comment is that they're the same. We're going to do a few more observations and investigating, and I'll draw some conclusions. Okay, next one we have log base 2 argument 16 minus log base 2 argument 8. So if we calculate that, 2 to the power of what is going to give me 16? 4. Okay, and we're subtracting. 2 to the power of what gives me 8? 3. So 4 minus 3 is 1. Here, if I just simplify this, this actually looks like log base 2 of 2. When the base and the argument are the same, do you guys remember?
1.
It equals 1. That's because 2 to the power of 1 equals 2. Or you could have put that in your calculator too, and went log 16 over 8 divided by log 2. And you'd get 1. So again, we're noticing the answers are the same. Okay, 3 to the power of what gives me 27? 3 and 3 to the power of 1 gives me 3. So here my answer is 2. And if we were to evaluate 3 to the power of what gives you 9? If I simplify 27 divided by 3, I get 9. And 3 to the power of 2 gives me 9. So again, we see that they are the same. Which leads us to the product and quotient laws of logarithms. So if we see that a logarithm has an argument that is being multiplied, we can rewrite that as an addition statement. So taking the arguments, we can separate them and have log of the same base, argument m, plus log of base a, argument n. So we're just taking the arguments and we're splitting them up. The bases have to be the same. Similarly with the quotient law, we can take the numerator, and that's going to be our first term for the logarithm, and then the denominator will be what we're subtracting. So using the product and quotient law, we're just going to evaluate a few more examples at the bottom. Okay, we're subtracting two logarithms. Do they have the same base? So if they have the same base, can I apply the quotient law? Yes. So I'm going to rewrite this as log base 2. And instead of subtracting two logarithms, I'm going to take the arguments, 12 and 3, and I'm going to divide them. Because the 12 came first, that's going to be the numerator. And the 3 is the second term, so that's in the denominator. And you always go in order from left to right, just like BEDMAS. Okay, and then we just have to evaluate. So 12 divided by 3 is 4. And we can convert to exponential form. We can divide log 4 divided by log 2. Or we can think 2 to the power of what gives me 4? 2. You guys are getting quick at these. It's good. Okay, next one. We have 3 terms. Let's just go in order. And first check, do they all have the same base?
Yes.
Yes, so we can apply the product and the quotient laws. Let's just start with these two terms. We have log base 6. What do I do with the 9 and the 8? Multiply, good. Okay, and then I would be subtracting log base 6 of 2. I'm just going to go through this one slow. And then hopefully eventually you can see we can actually go a lot quicker. Okay, now we have the same base, but we're subtracting. So what can I do with the arguments? I can divide. Okay, apply the quotient law. Then from there I get log base 6, 36. And to evaluate, I go 6 to the power of what gives me 36? 2. And up. Now, if you're wondering how I can do this a lot quicker, okay, I can just write it as a logarithm base 6, 9 times 8, because I'm adding. Okay, these two logs are adding, but then I'm subtracting this one, so I can just put the 2 in the denominator. And you can calculate it all in one step. So if you want, you can just do it all at once. For this next example, we're going to write the logarithms as a single log. Okay, so instead of having 4 separate terms, we're going to just have one single logarithm. So first, because these are addition, let's group those together. And we can use the product law. Okay, we're going to apply the product law in the first set of brackets, and the product law in the second set of brackets. So for this first set, we get log base x. We're going to multiply 10 times 75. So just taking these arguments and multiplying them. we're subtracting log base x, and in the second set, again, we're adding the two logarithms so we can multiply the arguments 2 times 3. So just cleaning things up, we get log 750 minus log 6 with base x. Because we're subtracting, we can apply the quotient law now, which means we divide our arguments. We get log base x of 750 divided by 6. You guys can help me out there. What do we get? 125? Thank you. How are we so far? Alright. Okay, part B, they're telling us evaluate if x equals 5. So we're just going to replace the x with 5. And to do this, we can just think about it. 5 to the power of what will give me 125? 3. Good. Okay, similar question in 3. Use the law of logs to write this expression as a single log. So we'll just start by looking. Do we have all the same base? Yeah, so we can use the power or the product and the quotient laws. We have log base b. We're adding these two, so it's 2 times 3. And we're subtracting 6. So log base b 6. If we're subtracting, where does it go? In the denominator. And again, we're subtracting log base b, argument 8, so where would the 8 go? We're subtracting that log. Goes in the denominator again. So we get log base b, 6 over 48. And when we simplify, we get log base b, 1 over 8. If you want to do these steps slower, you can. For example, if you wanted to group this together first, you get log base b 2 times 3. And then maybe you wanted to factor that negative out. So then you would get log base b 6 plus log base b 8. Here we get log base b 6 minus, we can use the product law, log base b 48, so I multiplied 6 times 8. And now that I'm subtracting, I can use the quotient law. So I get 6 divided by 48 as my argument. And then we're just back to where we were. Log base b, 1 over 8. So if you want, you can go a little bit slower, but if possible, why not just plug it in all at once? Now for part B, we just have to evaluate if b equals 2. So log 2 of argument 1 over 8. Can you guys think in your head 2 to the power of what gives you 1 over 8? Negative 3. You guys are quick. But say that you couldn't remember that. 2 to the power of what gives you 1 over 8? You just have to convert again to a common base. So this would be 2 to the power of x equals 1 over 2 to the power of 3. And to get rid of that 2 to the power of 3 in the denominator, I just changed the sign of the exponent, which places it up in the numerator. And now that I have a common base, I can set those exponents equal. Okay, so x is equal to negative 3. Or some of you right away, you just figured it out in your head. Good job. Alright, this next question is multiple choice, so we have to figure out which expression below is equivalent to the expression given. We're going to use our product law and quotient law to figure that out. And just to note, you're going to have to be extra creative. This is why logs are so fun. So check out the bases, 2, 2, 2, 2. They're all the same, so we can apply the product and quotient law. We're going to get log base 2. These ones are being added, so what can I do with them? Multiply x times 2x. Okay, and then I'm subtracting these logs, so what do I do with this argument, x squared? I put it in the denominator. Same thing here, I'm subtracting this logarithm, so I can put it in the denominator. Then we just want to clean things up a little bit. So in the numerator I have 2x squared, in the denominator I have an x squared. So what happens to those x squared? Cancel out. You're just left with 2 over y. Okay, so these x's cancel out. So we've converted this to a single logarithm. But you take a look at all the answers, there's 2 terms. So this is where we have to think creatively and go, okay, well this is in quotient form. Can I expand this so that it's a subtraction sentence? And yes, we can. So we're going to use the quotient law to reverse this. So we get log base 2, 2, subtract log base 2, argument y. So here we use the quotient law. Still don't have the right answer, but if we have the same base as the argument, what does it equal? 1. So we end up with 1 minus log base 2 of y, which is D. So just remember with your quotient law, you can go from a subtraction sentence to a quotient statement, or vice versa, like we just did. Okay, next up, we have to determine the value of 3 times log base 2p minus 3 log base 2q, and then they tell us that p divided by q is equal to 8. So first, let's just deal with this statement here, and we'll consider p over q in a little bit. Okay, what do both terms have in common? 3. So why don't we factor that out? Let's just isolate the logarithms. Okay, who can tell me what law I'm going to use? If you're subtracting 2 logarithms with the same base, quotient law. Good. So we use the quotient law to simplify this a little bit, and we get 3 multiplied by log base 2 p divided by q. Now we have that p divided by q, which they told us was equal to 8, so I can just apply that into my expression. And I get 3 multiplied by log base 2 of 8. Just looking at the log and not the 3 out front, let's try and evaluate this. 2 to the power of what gives me 8? 3. So it's 3 times 3 equals 9. Good stuff. Is that it? Oh no, we've got the power law. Okay, so looking at this example, they're telling us that we can write 2 log x as log x plus log x. From that, we need to show that 2 log x equals log x squared. So let's just start out by writing 2 log x. Now would you guys agree? I have 2 markers in my hand. Yeah?
Yes.
Okay, thank you. But could I not say that I have a marker plus a marker?
Yes.
It's a very basic example, but here I have 2 logarithms. Can I not write that as 2 separate logarithms? Log x plus log x? We're just going to break this up into log x plus log x. Sorry for the lame example. Just needed the visual. Okay, so now we have log x plus log x. What base is on both of these logarithms? 10. Okay, if it's not written there, it's always assumed it's base 10. So they have the same base. What law did we just learn when we're adding the same base? What's it called?
Product.
Ah, good job. So we're going to use the product law. And that's going to give us log base 10. You don't have to write it though. X times x. Okay, you're multiplying the argument of the first logarithm times the argument of the second logarithm. From there we get log x squared. Again, you don't need to write the 10. Therefore, we have shown in this long sentence here that 2 logarithm x is equal to log x squared. Let's prove that 3 logarithm base 2 argument a is equal to log base 2 argument a cubed. So 3 log base 2 argument a, that's equivalent to adding 3 logarithms with the base 2 argument a. We're going to go log 2a plus log base 2a plus log base 2 argument a. So just writing it out 3 times. They have the same base, they're all logarithms, so we can apply the product law. And if we apply the product law, we just multiply all the arguments. So we have log base 2, and then argument a times argument a times argument a. So we get log base 2 a cubed. Take a look at both examples. Do you guys see any correlation between the 2 as the coefficient and the 2 as the exponent? Or perhaps the 3 as the coefficient and the 3 as the exponent? Basically, they're interchangeable. If you have a coefficient out front, it can be rewritten as an exponent on the argument. And so if we had to rewrite this expression, what would be equivalent to it? What did you get?
Log E C divided by
Very good. Okay, that exponent, or the coefficient a was just moved to the exponent. And that leads us to our third law, which is the power law. So if you have an exponent on the argument, it can be rewritten as the coefficient out front. We're just going to use that law to evaluate a few questions. So for number 6a, we have log base 4 argument 16 to the power of 12. What can I do with that exponent 12? Using the power law, what can I do?
Put it in the front.
Put it in the front. Good job. Okay, so we're going to use the power law. Just going to move this 12 out front. So we have 12 times log base 4 argument 16. Let's evaluate just the log, and we're not going to use our calculator. 4 to the power of what gives me 16? 2. So I have 12 times 2, we get 24. You guys liking laws of logs? Hey, what can I do with this exponent? Move it out front. So we have 21 log 10. Let's evaluate log 10. What do you get?
1.
How'd you get that?
10.
Good, we have to remember that that's base 10. 10 to the power of what gives you 10? 1. Okay? When you have the same base, same argument, it's always equal to 1. So we have 21 times 1 gives us 21. Okay, example number 7 we pretty much summarized in, I think it was the last lesson. And taking a look here, do you guys remember from the last lesson just about the concept of how logarithms and exponential functions, how they're inverses? Okay, so here we have base 6 on our logarithm, but within the argument we have an exponent with a base 6 as well. Whenever we have the same bases in the exponent and logarithm, it's always just going to equal that exponent n. And we can use the power law to show that as well. Okay, what can I do with that exponent n? Move it out front. And then I get log base 6 argument 6, which is just 1. So n times 1 equals n. Okay, and similarly, if we have an exponent with the base 6 and a logarithm with the base 6, they're inverse operations. So in this case, it's just going to equal the argument